In this video, we're going to do a demonstration of doing a hypothesis test for a paired sample. Now, although we know we're doing a hypothesis test for a paired sample, we will of course make sure we're comfortable with why it should be a paired sample. So we want to see if students really gain weight during their first semester as a college student. So we sampled 40 freshmen. So we know our sample size. And they're randomly selected, and their weights are measured in both August and December. So our first question is actually why this is going to be a paired sample. Well, keep in mind that we're measuring their weight. That's our quantitative variable. But we're doing so in both August and December. So those are our two groups that we want to compare. So we have our August and our December. So let's suppose that in August we sample a girl named Hannah. Now, because I sampled Hannah in August, is there anything I have to do now in December? Well, I have to sample Hannah again because their weight is measured in both August and December. So why then is this a paired sample? Well, it's paired because we're sampling the same students in both August and December. So there's our explanation for it. Now some more information was given to us. So we found the average difference when we did December minus August in weights was 1.8 pounds with a standard deviation of 6.5 pounds. We want to see if there is evidence to support that students gain weight in their first semester at college. We're going to use an alpha of 0.01. So important things that are given to me here. First, this order of subtraction is going to be needed. We're also given some key numbers. So this 1.8, this is our sample mean difference. So that's going to be our y bar sub d. And then we're given this 6.5, which is our standard deviation of the sample, but more specifically, the standard deviation of the sample differences. We want to see if there's evidence that students gain weight in their first semester, and we're given our alpha of 0.01. Alright, so let's go ahead and think through what our hypotheses are going to look like. We already discussed why it's a paired sample. So once I know it's a paired sample, that null hypothesis is set for me. We have that population mean difference is going to be 0. So there's no difference, there's no weight change in the students on average. Now for the alternative, again, there's two things that I need to know. I want to find that students gain weight, but I am also given that order of subtraction of December minus August. So let's do this on the side here to understand why our sign will point the way that it does. So if our order of subtraction is December minus August, three things could happen. We could get a positive number, a negative number, or 0. If I get a positive number, the first thing listed has to be bigger. So the December would be greater than August. If I got a negative number, December would be less than August. And if I got 0, that would mean that the two equal, which is where the idea of the null hypothesis is coming from. Now, if a student gains weight, which value should be higher, the December weight or the August weight? Well, the December one would be bigger than August. If you're ever unsure, you can always try a number. So suppose someone weighed 180. If they gained weight, they would have weighed less in August. So I can see here that I do actually have a December is greater than August, which also points me to this positive number, telling me then that for my alternative hypothesis, I'm going to have that same greater than sign that I see here, as well as the idea of it being positive would mean that it's bigger than 0. For our second step, we have that same decision rule that we always have had, so we're going to reject the null and instead believe the alternative if our p-value is less than our significance level of 0.01 given to us. For step 3, I need to first check my conditions. And again, keep in mind that those are on your formula sheet. So we already discussed in part A why they're dependent samples. Now, was it a random sample? Well, going back here, it just said 40 freshmen were randomly selected. It did not give us a ton of information about how they were chosen, but at least from what I know, there was no bias with how they chose those students. For our second condition, we either need the differences to be normal or have a sample of at least 30. Now for the differences to be normal, either one, again, I'd have a histogram to look at. I'm not given one here, but again, if I had one, I would look to see that it was unimodal and symmetric. Sometimes it may also just state in the problem that the difference is normal. Nowhere here in the problem has it told me that, so I have no way of assessing that. So how big was our sample? Well, we sampled 40 students, so we did sample at least 30, so we're good for that condition. And finally, the population standard deviation of the differences is unknown. Again, I have the sample standard deviation of the differences instead. Other part of step 3 is to do our test statistic calculation. So we're going to do our t. That looks like this. Notice we already have all these numbers labeled. We already have our y bar d to be 1.8. We already have our SD to be 6.5. And I already have my n to be 40. So we have all of the numbers to go ahead and plug in here. Showing a little bit of an in-between step here, just in case you don't get the numbers to match, and to be able to demonstrate something in Statcrunch here as well. We would get 1.75 to be our test statistic. Now moving on to step 4, where we're going to calculate our p-value. I will always draw the picture just so we understand what's going on. So remember, the t and z look a lot alike. The t has just been sat on a little bit. It's still centered at 0. I can still sort of put my little increments on here to help me out. The t we got was 1.75, which falls between our 1 and 2 standard deviations away. Our alternative sign is a one-tailed test, so we just have that greater than sign. Greater than sign telling me then to shade to the right. Now quite often we may just be using the output here to get our p-value. So you notice that it's given to us there of 0.0439, and you can see that our hypotheses match. It doesn't have the little d on there, but no big deal. The idea still matches. So our p-value is going to be 0.0439. So now going back to step 2, is that less than 0.01? Well, it is not. So we will not reject the null. So we will not believe the alternative. So then when we think through again our conclusion, we always start with our alpha level, which is 0.01. Now, because we did not reject, remember that that not comes down here as well. So there is not our statistically significant evidence. To support. Now, our alternative hypothesis, but in words. So there is not evidence to support a mean weight gain for first semester college students. In the next video, I'll show you how to get the Statcrunch output. But again, it's kind of showing where we saw some numbers. So of course, the p-value is there for us. But if I go back and look at my test statistic, notice that the 1.75 is showing up there. This 1.0278 is our standard error. And that sample mean is that 1.8 that we used. So again, in the next video, I'll show you how to get that Statcrunch output.